Good afternoon. This is the given pictorial diagram, and you have to find out in this arrow diagram, in this visual representation of the relation, this relation is a function of. That is your question. In this pictorial diagram, you have to find out whether this pictorial diagram, this arrow diagram, this visual representation of the relation is a function or not. So you can easily identify it. There is Vivek. This has not one and only one weight. The peoples and their weights are given, and Vivek has two weights. It has not one and only one. So in the definition of function, the first condition is not satisfied, because in this example, Vivek has two weights. Therefore, first definition of function is not satisfied. Definition of function. First definition of function is not satisfied. That is, each element of A has one and only one element in B. One element in B. In B is not satisfied. Therefore, hence, this is not a function. So you have seen two examples, one example on previous term on Saturday. So that was the function, because both the condition of the function was satisfied in that question, and here the first condition of the function is not satisfied. Therefore, this is not a function. So I have written the reason why this is not a function. Now you come to how we define the value of a function. Hence, f such that A to B is not a function, now value of the function. The element y belongs to B is associated to element x belongs to A is denoted by y is equals to fx. If x is A, then value of y at x equal to A is defined as y is equals to f of A. So now you see that value of the function, the element y belongs to B is associated to element x belongs to a is denoted by y equals to fx. If x equals to a, then value of y at x equal to a is defined by y equals to fa. Now, you see question. If fx is equals to x square minus 2x plus 3, find f1, f2 and f3. So how will you write a solution? See that given that f of x is equal to x square minus 2x plus 3, your f of 1 is obtained by substituting x is equal to 1 on both sides of the result 1. So f1 is equal to 1 square minus 2 into 1 plus 3, that is 1 minus 2 plus 3, it is 2. Now second is find f2, or we will find f2, that is 2 square minus 2 into 2 plus 3, that is equal to 4 plus 3 is 7, 7 minus 4 it is 3. Now f3 is 3 square minus 2 into 3 plus 3, 3 is 9, 9 is 12, 12 minus 6, that is equals to 6, 2 3 6. There, in this way you are finding the value of the function. Now definition of even and odd function. Now we are going to discuss the definition of odd function, and then by using that definition we prove some of the functions whether they are even or odd. So you see, even function. A function fx is said to be even if f of minus x equals to fx. For example, if fx is equals to cos x, then f of minus x is equals to cos of minus x is equal to cos x is equals to fx. So hence cos x is even function. Cos x is even function. So this is the definition of even function. I am revising that. A function fx is said to be even if f of minus x equal to fx. For example, if fx equal to cos x, and then you replace x by minus x on both sides, and if it is equal to, you are obtaining certainly it is equal to fx, so cos x will satisfy the definition of even function, therefore it is even function. Now next one is odd function. A function fx is said to be odd if f of minus x equals to minus fx. For example, if fx is equals to sin x, similarly you find f of minus x is equal to sin of minus x is equal to minus sin x equals to minus fx. Therefore sin x is an odd function. So these are the definition of even and odd function. So now we are doing some question on the basis of that question. Question. determine 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 whether the function given below, whether the function is even or odd or neither even nor odd. I am taking so many examples. Your first part A, number 1, your fx is equals to mod of minus x. Second, fx is equals to mod x. Third, fx is equals to mod x minus 2. Fourth, fx is equals to minus x mod x b part. If fx is equals to x square plus kx plus 1 for all x and f is even function, then find k. That is the question. Now you see, your first part. A fx is equals to mod of minus x. Given that fx is equals to mod of minus x. Now you find f of minus x for that. So that is equals to mod x. This is equals to mod of minus x, that is equals to fx. So here f of minus x is fx, implies that fx is even. That is the answer of first. This is the answer of first question. Fx equals to mod of minus x, that is given fx this much, f of minus this, then you have obtained f of minus x is fx. Therefore fx is even. Now come to second. In second you have given that fx is equals to mod x. F of minus x is equal to mod of minus x is same as mod x, that is equals to fx. Here again f of minus x implies fx. Implies that fx is even. Now you see second part. In this question, when you find f of 2, f of 2 is mod of 2 minus 2, that is equals to 0. F of minus 2, that is equals to mod of minus 2 equal to mod of minus 4 equals to 4. This implies that f of 2 is not equal to f of minus 2. Therefore, fx is neither even nor odd. We have taken two value of x for that, 2 and minus 2, positive and negative will be even function. What you are doing? You are replacing the given variable x by minus x. So similarly you are replacing the value of x by 2 and minus 2. In one case you opt in 0, in another case you opt in 4. and f2 and f of minus 2 both are not equal, therefore fx is neither even nor odd. And what about this? Given that fx is equals to minus x mod x. So now you find f of minus x, that is equal to x mod minus x. So this can be written as x mod minus x, x mod minus x is same as x mod x, x mod x. It has changed the sign. Fx is minus x mod x. F of minus x, the sign is changed. That is equals to minus fx. Now you have obtained f of minus x equals to minus fx. It implies that fx is odd. So these are the 4 questions here I have taken just to explain you how we show a given function is even or odd. Now second part, you have already given that this fx defined by this is an even function. So then find the value of k. Your fx is given to be b part. Solution of b part. Fx is given to be x square plus kx plus 1. Since we have given that fx is even function, therefore f of minus x equals to fx. This is 1. Now you find f of minus x. That is minus x whole square plus k into minus x plus 1. So f of minus x is x square minus kx plus 1. And fx is x square plus kx plus 1. So this is 2, this is 3. By using 2 and 3 in 1, we get x square minus kx plus 1 is equal to x square plus kx plus 1. 1 and 1 will be cancelled, x square and x square will be cancelled, 0 equal to 2kx, 2kx equals to 0. Since we have given that x is any real number, so 2k is 0, so implies that k is 0. So in this way you can obtain the value of k. Your k is 0. Another question. Question: if fx is defined as 1 plus x, if minus 1 is less than or equal to x is less than 0, x square minus 1, if 0 is less than x is less than 2, and this is 2x if x is greater than or equal to 2. Then find f3, f of minus 2, f0, f of 1 by 2, f of 2 minus h, and f of 1 minus h, f of minus 1 plus h, not 1 minus h, minus 1 plus h, f of minus 1 plus h, where h is greater than 0 and very small. It is very small. That is the question. So from this given function, we can write from the given function, we can write fx equals to 1 plus x if minus 1 is less than or equal to x is less than 0. So when your value of x is from minus 1 to 0, your function fx is 1 plus x, and next one, your fx is x square minus 1 if 0 is less than x is less than 2. It means when your value of x is taken from 0 to 2, in that case fx is equal to x square minus 1, and third one is fx is 2x if x is greater than or equal to 2. When value of x is from 2 to infinity, it is from 2 to infinity, in that case your fx is 2x. So your function, I have written your function in bifurcated form. Okay, what is the function when x is from minus 1 to 0, what is fx when x is from 0 to 2, and what is fx when x is greater than 2. So first of all, you see that in first case you have to obtain f3. This f3, this 3 is greater than 2. So when x is greater than 2, your function is 2x. So your value of f3 is 2 into 3, that is 6. Now next one, you obtain minus 2. Minus 2 does not lie in any range of the value. So f of minus 2 is not defined. You are not able to find out the value of f of minus 2 from this given information, because for at x equals to minus 2, the function is not mentioned. This minus 2 is beyond the range of x given in the question, so we cannot calculate. F minus 2 we cannot find. We cannot find because minus 2 is not in the range of x, given x. Not in the range of given x. Try to understand. So next one, find f0. We cannot find f0. What about f0? f0 does not exist because fx is not defined, when x equals to 0. Now next one is find f of half. F of half lies between 0 and 2, and for this our fx is x square minus 1. So f of 1 by 2 is 1 by 2 whole square minus 1, 1 by 4 minus 1. It is minus 3 by 4. In this way we find f of half. Now next, calculate f of 2 minus h. minus h. Now 2 minus h is in the range of 0 is less than x is less than 2, and in this case your function is x square minus 1. So f of 2 minus h is 2 minus h whole square minus 1, 4 minus 4h plus h square minus 1, and that is equal to h square minus 4h plus 3. So your f of 2 minus h is this much. Last one is f of minus 1 plus h. You have to calculate f of minus 1 plus h. In order to find f of minus 1 plus h, you find the range of minus 1 plus h is minus 1 is less than or equal to x is less than 0. So in this case your function fx is 1 plus x. So therefore f of minus 1 plus h is equal to 1 minus 1 plus h. 1 and 1 is cancelled and this is h. So consequently f of minus 1 plus h is h. So you remember all that things. Now question. You see another question. If fx equals to x to the power 4 plus x square minus 2, then find f of x minus 1. So now in this case you see that when you write the solution, so first of all you write down, given that f of x is equals to x to the power 4 plus x square minus 2, so f of x minus 1 is equal to, you are replacing just x by x minus 1. You replace x by x minus 1 on both the sides. So here you have written x minus 1 in place of it. You write x minus 1 in place of it on right hand side also. So it is x minus 1 to the power 4 plus x minus 1 to the power 2 minus 2, and you simplify. That is equals to x minus 1 whole square of that plus x square minus 2x plus 1 minus 2, and here x square minus 2x plus 1 whole square plus x square minus 2x minus 1. So by using the formula a plus b plus c whole square, you solve them. It is a, you know that a plus b plus c whole square is equals to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Use at this step you can write x to the power 4 plus 4x square plus 1 minus 4x cube minus 4x plus 2x square plus x square minus 2x minus 1. So this one and this one will be cancelled. It is x to the power 4 minus 4x cube, then 4x square plus 3x square is plus 7x square, and again come to x minus 2x and minus 2x is minus 6x. So in this way you can find f of x minus 1 in this question. Now another question. If y equals to fx equals to 3x plus 1 upon fx equals to y equals to fx, equals to 3x plus 1 upon 5x minus 3. Prove that x is equals to fy. So now you see that x equals to fy. So from here you calculate, first of all you write given that. Solution. Given that fx is equals to 3x plus 1 upon 5x minus 3. Now from this you can find fy by replacing x by y. So it is 3y plus 1 upon 5y minus 3. This is 1. So since y is equals to fx, suppose this is 2, this is 1. Since y is equals to fx, therefore 1 can be written as y is equals to 3x plus 1 upon 5x minus 3. 5xy minus 3y is equal to 3x plus 1. Now 5xy minus 3x equal to 3y plus 1. So x in the bracket 5y minus 3 is equal to 3y plus 1. From here your x is 3y plus 1 upon 5y minus 3 using 2. So you can write x is equal to fy. So in this way you can do these type of questions. Now again I am coming to pictorial diagram. There are some questions given and you have to identify out of them which are function and which are not a function, and if it is not a function, give reason, and if they are function, then find the domain, codomain and range of the function. First of all, I am writing question. Which of the following are function? Which of the following are function? If it is a function, then write down its domain, codomain and range of the function of the function. Now first part, I am doing for, there are five questions. There are 5 questions in this, and you have to do all. Your first set is having members Rama, Kareem and Sushma and Lata. And in second set B, this is your second set B, it is 45 kg, this is 50 kg, this is 55 kg and this is 60 kg. Now this is the question, this is the first part. You have to find out whether this given pictorial diagram is a function or not. If this is a function, then you find domain, codomain and range of the function. So now you see of what I have told you to prove any given relation is a function. What are the conditions to prove? In order to prove this relation is a function, what you are going to prove? First of all, you listen that. First in that, For it is to be a function, it is necessary that all the elements of this set A in which the persons are given, they are associated with element of B. That is the first condition. All the members, each member of A are associated with the element of B. And second condition, each element of A is associated with one and only one element of B. Here all the elements of A are associated. First, here all the elements of A are associated with element of B. All the elements are associated with the element of B. Second, each element of A is associated with one and only one element of B. So now you see both the conditions are satisfied. Therefore, f such that A to B is a function. Now what is second? Second part is that you have to find the domain. What is the domain of this function? Domain of f consists of Rama, Kareem, Sushma, and Lata. And what is the range of this function? Your range of f is equals to their weights 45 kg, 50 kg, 55 kg and 60 kg. What is the codomain? Codomain of f is equal to set B and it is equals to 45 kg, 50 kg, 55 kg and 60 kg. So in this way you can tackle this type of question. When visual representation of any relation is given and you have to identify whether that visual representation represents a function or not, you have to test these two definitions. If that two part of the definition are satisfied, then that is a function, and this is called domain and this is called codomain, and the subset of B, which are the collection of image element of A, is called the range of the function. And in this example your range of the function and codomain is same. So now come to second question. There is second question. Second. This is A, this is B. Your A consists of the member Rasika, Rekha, Surinder, Anu, and their weights are 40 kg, 60 kg and 65 kg. Now you see that their association are shown as Surrender, rate is this, Anu has this. Now again you have to find out whether this visual representation of the relation is a function or not. So in this case you see that two members have the same weight, but all the members of A is associated with the element of B. It means the weight of each member of the set A is shown here. So here in this example, first condition, all the elements of A is associated with the element of B, and second, each element of A is associated with one and only one element of B. So both the condition is satisfied, therefore answer that A to B is a function. I am not talking about the type of function, only function, this is a function. Now then you find their domain, your domain of F is equals to Rasika, Rekha, Surinder and Anu. The range of F is equals to codomain. Both are equal, that is equals to 40 kg, 60 kg and 65 kg in this. So you can define. Now I am taking next question. Your third part. A, B. A is Arun, baby, Shankar, and Fatima. B consists of 50 kg and this is 60 kg and this is 65 kg. So here Arun associated with that, baby this and Shankar this. So now you have to identify whether this relation is a function or not. So here first condition is not satisfied. Your first is not satisfied. In first, Fatima, which is a member of A, is not associated with member of B. Therefore, F such that A to B is not a function. Your first condition of the function is not satisfied, therefore this is not a function. And no need, how can you find the domain and range of the function? So we end our answer here. Now next is fourth. A, B. Here Pyare Singh, first member is Pyare Singh. Second member is Thakur Singh. And Avatar Singh. And Jaswant Singh. And here 65 kg, sorry 60 kg, 65 kg and 66 kg, 68 kg. Here you see that Pyare Singh has two weights and Thakur Singh this. Now here first condition is satisfied. First condition is satisfied. But what about second? Pyare Singh is associated with two members of B. Therefore, second condition is not satisfied. Hence, f such that a to b is not a function. So, I have taken these are the examples to explain you what is function, and I have told you whenever you have any confusion regarding that, you remember my one line. Driver knows the application of all parts of a vehicle. You remember this sentence always, and that will give you the clear picture of the definition of the function in your mind, and then you proceed. Now, another is real valued function. Another is real valued function. Now, I reach to real valued function. Real valued function. A function f such that a to b is a real valued function. Real valued function. Real valued function. If a and b are subset of R. R is set of real numbers. You remember that. In other words, you can say that if a and b is a subset of set of real number, then f such that a to b is called a real valued function. In other sense, you can define it this way also. Now, characteristic of function. Now you see what is the characteristic of function. Characteristic of a function. Function R में f such that a to b. First characteristic. for each element of x belongs to A, for each element of x belongs to A, there is unique element y belongs to B. This is the first characteristic. Second, the element y belongs to B is the image element of x belongs to A. This is second characteristic. Now third, if f such that A to B is not a function, in that case there are two conditions. Number one, all elements of A, not all elements of A not have the association. The association with any element of B. Any element of B. Second, one association of the element of A has more than association of the elements of A has more than two. Association of the element of A has more than element of A has. Second, the element of A has more than one association. More than one association. So these are the characteristics of the function. These are the characteristics of the function. Now, next, what is the difference? Note. This is very important. This is very confusing whether function is the subset of relation or relation is a function, is a subset of function. So I am writing that. Note. First note is function is a subset of relation. It is a subset of Cartesian product. Relation is a subset of Cartesian product of two sets A and B. And second is every function is a relation, but every relation is not a function. Every relation is not a function. Now, difference between relation and function. How you identified that this is a relation and function. So that is use of that in the question. Then you know what is the difference of relation and function. If you know, you can apply it. So now next thing is the difference between relation and function. Here domain, and there are two things, domain and association. On account of that, we can identify a relation and function. There are two elements, domain and association. On the basis of that, we can identify which one is the relation and which is the function. Now relation, this is one column and this is function. You remember this one. So first of all, domain of R may be a subset of A. May be a subset of A. Maybe, not confirmed. It may be, it may not be. May be a subset of A. Here, domain of function f, domain of f, domain of f is equal to A. Here, element of A, element of A has more than one association, more than one association, more than one association. But in case of function, element of A is associated with one and only one and only one element of B. That's all for today.